calculus students. Today we have section 5-6, solving exponential and logarithmic equations. I know this is something you've always wondered your whole life how to do. Good news, we're going to go through it exactly how to do this. And the key here is we're going to use the fact that if we have an exponent equation like this with base b to the u power equals b to the v power, if the base is the same, we know the exponent has to be the same. So u has to be v. And we can do the same thing with logs. As long as it's the same base of the log, the inside of the logs have to be equal. If those expressions are equal, log base bu equals log base bv. Again, if the log has the same base, the insides u and v have to be the same. Alright, so the way I'm going to do this, I'm going to go through some exponential equations, then I'm going to go through some logarithmic equations, and after all that fun, you will be able to solve any of those two types of equations. So first we have 9 to the x equals 3 to the x minus 1. Now we want to try and get the same base, so we say, okay, 9 we can rewrite as 3 squared. Use our rules of exponents to multiply the exponents. So I get 3 to the 2x equals 3 to the x minus 1. Now, since I have the same base, I can set the exponents equal to each other and solve, and we get x is negative 1. Okay. Next example, 4 to the 2x minus 1 power equals 5 to the 1 minus x. Now the first thing I'm going to tell myself is I can't write 4 and 5 in the same base. Like in the earlier problem I could do 9 and 3, I could write 9 as base 3. So if I can't write them in the same base, I'm going to have to use the logarithm. You can use whatever logarithm you want, I just chose natural log here. It doesn't matter as long as you use the same one on each side, because the logarithm is really good at reaching up, grabbing that pesky little exponent, that annoying little bugger up there, and then just throwing it out in front, making it much more vulnerable to be solved, and we can isolate it much easier when it's not in the exponent spot, our variable. So the exponent gets thrown in front by the logarithm, so I have 2x minus 1 times ln of 4 now, and then the other exponent gets thrown out in front, so it's 1 minus x times ln of 5. Now I just got to solve for x, so I'm just going to do some tedious multiplication. 2 times ln of 4x minus ln of 4. Distributing some multiplication here, ln of 5 minus ln of 5 x. And I'm going to get all the x's on one side, so I'm going to add ln 5x. When I say 5x, I mean it's ln of 5 with x on the outside multiplied, so it's not like the x is inside the logarithm there. And then add ln of 4 to the other side. So that basically everything with an x is on one side, everything that doesn't have an x goes on the other. So now I get 2 ln of 4 times x plus ln of 5 times x equals ln of 5 plus ln of 4. Alright, now we're really cooking here. Since everything on the left hand side has an x, I can factor it out, pull it out, so I'm going to go ahead and do that. So when I pull the x out, the first term becomes 2 ln of 4 plus second term is ln of 5 equals ln of 5 plus ln of 4. And if at any point you want to like plug these numbers in the calculator, you're welcome to do that. And then subtract by the big old thing that's multiplied by the x. So that would be my final answer. I would just get ln of 5 plus ln of 4 over 2 ln 4 plus ln 5. And definitely going to use my calculator here. Put all that in, and then beep, boop, beep, boop, boop. It's going to do the work for me, getting those nice logarithms. And it's going to tell me that the answer here is x equal to 0.6836 approximately. All right, we solved another one. Let's do one more, and then we'll do some logarithmic equations. So this one, let's see what we got. E to the x, again, e is just that 2.718, that special number that is useful. It's the base in a lot of exponential functions that model some real world stuff. So we have e to the x minus 5 e to the negative x equal negative 6. Now the first thing, I don't like negative exponents, so I can make it positive by dropping it downstairs. And I don't like fractions, so I'm going to get rid of the fraction by multiplying by the denominator, which is e to the x. So that's my first plan of attack. Okay, so then I'm going to get e to the x times e to the x, which is e to the x squared, minus, well now it's just 5. The whole purpose of this was to get rid of the fraction, minus 6 e to the x. And what I realize here is I want to get all the x's on one side, so I'm going to add 6 e to the x. And I look at this and I say, well, if e to the x was just some variable, let's say u, then I would have a quadratic equation. It would just be u squared plus 6u minus 5. So, and then I can just substitute back in once I've solved what u is. So that's what we're going to do. We're going to say u equals e to the x. We're going to sub it in. So everywhere I have an e to the x, I'm going to put a u. So I get u squared plus 6u minus 5 equals 0. And this is a quadratic, and I'm going to try and factor it. And I'm going to realize that it doesn't factor, and I'm going to be sad, because that means I have to use the quadratic formula if it doesn't factor. But I know the quadratic formula. It's the only thing in math that I have memorized. I don't have anything other than this memorized. So it's the opposite of b, so it's minus 6 plus or minus b square root of b squared minus 4ac all over 2 times a. And I start doing the quick maths. So under the square root, I've got 36 plus 20. So now I've got minus 6 plus or minus square root of 56 divided by 2. And we know how to simplify square roots. We're looking for perfect squares under there. So any perfect squares that go into 56. Well, the first one I should try would be 4. And I realized that, yeah, 4 goes into 56. It's 4 times 14. So since 4 is a perfect square, it's a factor of 56. I can pull it out of the square root. So now I have minus 6 plus or minus 2 root 14, and then divide the 2 into each part of the addition here. So 2 goes into negative 6 to give me negative 3, and it goes into 2 evenly for just be left with 1. I don't know why I just stuttered like crazy there. And we get minus 3 plus or minus root 14. So those are our two answers. But we have to be a little bit careful, because that's not the final answer. Remember, we did this substitution where we said u is equal to e to the x, but we don't want u, we want x. So at the very end here, I got to go back and I got to say, well, I got to put e to the x in for u and solve for my two answers. So I have e to the x equals minus 3 plus root 14, or that e to the x equals minus 3 minus root 14. So how am I going to solve this? Pause and think about what you would do. Yeah, natural log is a good idea. So it's going to be the inverse of the exponential base e. So it's, if I do natural log on each side, then on the left-hand side, ln and e is going to cancel. So I'm just left with x. So x equals ln of minus 3 plus root 14. And I have x equals ln of minus 3 minus root 14. But wait. Hang on a second. The ln, we can't put a negative number in the ln. Remember, it's undefined. So this second answer is what's called a extraneous solution. It's not that we did the math wrong. The math was all right, but when we did the substitution, with the u substitution, you have to be careful, because you can sometimes create answers that won't work when you sub back in. So whenever you do those kind of substitutions, you want to be careful and check your answers. So that second answer doesn't work, because again, you can't have a negative number inside an ln, but the first one does work. Ln of negative 3 plus root 14, because root 14 is bigger than 3, right? So that's still going to be ln of a positive number. In fact, the answer is negative 0.2989. Whew. Okay. Well, now that all that fun with exponential functions is out of the way, we can get to the logarithmic equations. How are we going to solve these puppies? Okay, first example for you. Natural log of 4x minus 1 equals, plus ln natural log x plus 2, equals 2ln x. Now my thought process is I want to get ln equal to an ln, and then I can set the insides equal to each other. So I just want one ln. So how do I combine two natural logs that are added? Well, remember, we can smush them together as long as we multiply the insides. So on the left side, I'm going to get ln 4x minus 1 times x plus 2. And how do I get just an ln on the right side? Well, we can, remember, if there's a number in front, we can move it up to the exponent part if we want. And in this case, we would, so that we can have ln of something equals ln of something, and then set those two insides equal. So that's our strategy. So we do some foiling on the inside here, and we go ahead and combine the middle terms. So I'm going to get 4x squared plus 7x minus 2 equals ln x squared. Now I have ln of something equals ln of something. That means those two things in the middle have to be equal for that to be true. So I can just jump right into, the 4x squared plus 7x minus 2 has to be x squared. So I set them equal to each other, and use my masterful algebra skills to solve for x. So minus x squared, try to factor this. I try and factor it for a while, and then I realized, darn it, that's another one that I can't factor, so I gotta use the quadratic formula again. Good thing it's the one thing I have memorized in math though. So I'm using my quadratic formula here. My voice is getting tired, so I'm going to not say all the numbers. I'm just doing the quadratic formula here, as you can see. Okay, so let's see. Under the square root, so I have x equals minus 7 plus or minus 49 plus 24 would be 3, carry the 1, 73 over 6, but 73 is a prime number, so there's no perfect squares that go into it, so I can't get it any more simple. So my two answers are minus 7 plus root 73 over 6, or minus 7 minus root 73 over 6. But again, be careful. You want to make sure that you check your answers. So the first one is about 0.2573, 0.2573. The second one is negative 2.5907. Now, the thing is, I want to check my answers and make sure that I'm not doing things like putting a negative number into a log function, since we know the domain has to be positive numbers, right? Domain of the log function is the inputs have to be bigger than 0. So when I go back to the original equation, over here on the right-hand side, I have an ln of x, so x can't be negative. So that second answer is another, what we call extraneous solution. That's what the math nerds call it. And it just means it's a solution, it's an extra solution that came up when we were doing our math, but when we go back and try it in the original equation, it just doesn't work, man. So you have to throw it out. It's garbage, it's trash. But we can keep the other one. The first answer is okay, 0.25, because if you plug it into the original equation, 1, it's going to work, and 2, you're not going to get any negative numbers that you're going to try to shove into the logarithmic function. So just check your answers. That's the moral of this story. Okay, I think I have 1 or 2 more examples for you. I know you're dying for more, so let's continue. All right, I've got log, this time base 10, the common log x plus 2 equals 1 minus log x minus 1. Now my thought process is I want to get all logs together, so I'm going to add this negative log here to the other side. So now I have log x plus 2 plus, okay, so back to where we were. Log x plus 2 plus log x minus 1 equals 1. Now we can combine this into one log. If we add 2 logs, we can combine it into one log as long as we multiply the inside. So we can do that. Log of x plus 2 times x minus 1 equals 1. I'm going to FOIL. I'm going to bust out the FOIL action. So I get x squared plus 2x minus x minus 2 is equal to 1. Now, what am I going to do here? I am going to combine the middle terms, so x squared plus x minus 2 equals 1. Then I am going to convert into the exponential form, because if I'm ever stuck on a log expression, I can always transform it to the exponential version. And I promise you, the thing is, I will tell you this, if you're ever stuck on a log problem, probably if you transform it to the exponential version, I bet you'll be able to do it. So we do that here. The base is 10. The log is the exponent, so that means 1 goes in the exponent spot. It's equal to the thing inside the log. Now it's just a quadratic I can solve quite easily. Subtract 10 to each side. I get x squared plus x minus 12. Finally, a quadratic that I can factor where I don't need to use the quadratic formula. And I get two answers, x equal minus 4, x equal 3. But I'm remembering that I need to check these because I don't want to have a negative number go into the log. So if I put in -4, that first one's going to be -4 plus 2. Log of -2 is going to be undefined. So another extraneous solution, throw that garbage out of here. But x equal to 3 is fine because in the first log, it's 3 plus 2, so that's log 5. That's fine. And then the second one, it's going to be a positive number as well. All right, thanks for hanging through this one. It was a little bit of a longer video, but if you go through all these examples, you'll be a master of solving any equation that use logarithm or exponent. Thank you very much, and I'll see you in next class.